Welcome to Basic Electrical Engineering lecture series. This is a series of lecture videos for the first year engineering and electrical diploma students. In these videos, fundamentals of DC and AC circuits, network theorems, fundamentals of transformers, DC and AC machines, and renewable energy sources are the topics covered. Sufficient number of numericals are worked out in each session to make the concepts clear to the viewers. For a basic idea about the topics mentioned, please watch these videos from the very beginning itself. If you find the videos useful, please subscribe for the channel, like the video and press the bell icon for notification. Please try to wear a headphone and watch the video for better sound clarity. Thank you all. And now let's start with today's session. So what is covered in today's session is parallel AC circuits, and we'll be covering or working out some problems in parallel circuits. So the first question is a parallel combination of two impedances Z1 is equal to 6 plus J8 and Z2 is equal to 4 minus J3 takes a total current of 10 ampere when connected to a source. Find the branch currents. Now this is similar to an ordinary DC circuit. So if two resistors are connected in parallel in DC circuits, two resistors are connected in parallel, say R1 and R2, and a total current of 5 ampere is flowing to the circuit. So what will be the branch current? Say current through R1 is equal to I1, current through R2 is equal to I2. So how we find it out? So I1 is equal to incoming current I into resistance on the opposite side, that is R2, divided by sum of the resistances, that is R1 plus R2. Same rule can be applied here. So here instead of resistance, these are impedances, but we can apply the same rules. So there are two impedances Z1 and Z2. Let's say the current through Z1 is equal to I1, current through Z2 is equal to I2. So I1 is equal to incoming current. So it's given that incoming current is equal to 10 ampere. So let's take that quantity as the reference, that is 10 angle 0. So 10 angle 0 into impedance on the opposite side, that is 4 minus J3 divided by sum of the impedances. Sum of the impedances is 6 plus 4, 10, 8 minus 3, 5, 10 plus J5. That is Z1 plus Z2. So current through Z1 is equal to incoming current I, that is 10 angle 0 into impedance on the opposite side, that is Z2 divided by sum of the impedances. Sum of the impedances is 6 plus 4, 10, 8 minus 3, 5. So 10 plus J5. And I2 is equal to 10 angle 0 into opposite side impedance, that is 6 plus J8 divided by 10 plus J5. So these are to be converted to corresponding polar coordinates and can be solved. So current through Z1 is equal to I into 4 minus J3 divided by 10 plus J5, that is 10 into 4 minus J3 when converted to polar coordinates, 5 angle minus 36.86. 10 plus J5 is 11.18 angle 26.56. So 10 into 5 divided by 11.18. So magnitude is 10 into 5 divided by 11.18, that is 4.472 angle, minus 36 minus 26, minus 36.86 minus 26.56, that is 63.42. So current through Z1 is equal to 4.472 angle minus 63.42. Similarly, I2 is equal to magnitude 10 into 10 divided by 11.18. That is 10 into 10 divided by 11.18 angle 53.13 minus 26.56. 53.13 minus 26.56. 10 into 10 divided by 11.18 is 8.944. 53.13 minus 26.56 is 26.57. So these are the branch currents. Now the next one. A parallel circuit has got two branches as shown in figure. Find the total current drawn from the mains and the total power consumed. So first branch, it's an inductor is connected in series with a 10 ohm resistor. Inductor value 10 millihenry. Second circuit, a 1 millifarad capacitor is connected in series with a 10 ohm resistance. So to find out the currents, first we have to find the reactance values. So inductive reactance XL is equal to omega L is equal to 2 pi FL is equal to 2 pi into frequency is 50 Hertz. So 2 pi into 50 into 10 millihenry, 10 into 10 to the power of minus 3. And capacitive reactance 1 divided by 2 pi Fc, that is 1 divided by 2 pi into 50 into capacitor value is 1 millifarad, 1 into 10 to the power of minus 3. So XL value is, so XL is equal to 3.14 ohm and XC is equal to 3.183 ohm. So the circuits can be redrawn like, so first branch is 10 plus J 3.14 and the second branch is 10 minus J 3.183. Now current through the first branch, let's take it as I1, this current as I2. So I1 is equal to, that is the applied voltage is given, that is 220 volts. So I1 is equal to 220 angle 0, there is no other quantity given as reference, and this 220 volt, let's take it as the reference quantity. No angle is given for that, so let's take its angle as 0. So I1 is equal to 220 divided by 10 plus J 3.14. And I2 is equal to 220 angle 0 divided by 10 minus J 3.83. So we can find out the values of I1 and I2. That is I1 is equal to, so 10 plus J 3.14 is 10.481 angle 17.43 dividing That is 220 divided by the, so when we divide these quantities, 220 divided by 10.481 angle 0 minus 17.43. That is 220 divided by 10.481, 20.99. 0 minus 17.43 is minus 17.43. Similarly, current drawn by the capacitive circuit, that is I2 second branch, is equal to 220 angle 0 divided by 10 minus j 3.183. So 220 angle 0 divided by, when this rectangular quantity is converted to polar, it is 10.494 angle minus 17.65. 220 divided by 10.494 is 20.964. Angle 0 minus minus 7 is plus 17.65. So these are the current drawn. So total current we can find out by adding these two branch currents. So I1 is 20.99 angle minus 17.43. I2 is 20.96 angle 17.65, and added to convert these polar terms to corresponding rectangular terms, add it, simplify it. So total current will get it as 40 angle 0.09 degrees. That you can neglect, 40 ampere you can take. So total power is consumed by these two resistors R1 and R2. Inductor or capacitor won't consume any power. So power consumed by R1 is equal to I1 square R1. Power consumed by R2 is I2 square R2. We know the magnitudes of I1 and I2. So I1 square R1 plus I2 square R2 will give you the total power. So I1 is 20.99 square into R1 is 10. I2 is 20.964. So I2 square into R2, that will give you the total power, 8801 watt. Now you can find it out by an alternate method also. So we know the impedances. First branch 10 plus j 3.14, second branch is 10 minus j 3.83. Find out the equivalent impedance. So find the equivalent impedance, and applied voltage divided by equivalent impedance will give you the total current. Then we can divide it between the branches. Like that also it can be, these branch currents can be found out. Branch current are not required, actually only total current is enough. So we can find the equivalent impedance. Z equivalent is equal to Z1 Z2 divided by Z1 plus Z2. So applied voltage divided by Z equivalent will give you the total current. So square of the total current into equivalent resistance. That means Z equivalent is on R equivalent and X equivalent will be there. X. It can be capacitive or inductive reactance. So in Z equivalent, so I you will get by dividing V divided by Z equivalent will give you the magnitude of Z equivalent will give you the value of I square into whatever R you are getting here. That will give you the total power consumed by the circuit. That way also we can find it out. Now phasor diagram. Now we are taking V as the reference. That is V. I1 we got it as 20.99 angle minus 17.43. So this is I1. I1 is 20.99 angle minus 17.43. I2 is 20.9 angle 17.65. 20.9 This I2 is 20.99. I2 is 20.96. I1 20.99. I1 is 20.99. This is 20.96. And the total current can be found out by, so if we neglect the small difference, complete the parallelogram, draw the diagonal, that will give you I. I is 40 ampere. I1, this is I2, add I1 and I2, complete the parallelogram, draw the diagonal, so that will give you the resultant current. Resultant current is 40 ampere. That is angle, we are neglecting it, so it is in phase with the voltage. Because the inductive and capacitive reactances are almost equal. So I1 angle also, I2 angle is 17.65. This is 17.65. And I1 angle is minus 17.43. So almost equal. So that is the phasor diagram of the circuit. So next question. The total current drawn by a parallel circuit comprising of three impedances is 10 ampere. Find the current drawn by each branch. That means the first branch a 10 ohm resistor, second branch a 10 ohm resistor and an inductive reactance of 3.14 ohm. Third branch 10 ohm resistor, capacitive reactance 3.18 ohm. We have to find out the branch currents I1, I2, I3. So let's find the equivalent. So we can find the equivalent impedance. So total current is given in the question. So total current into equivalent impedance will give you the voltage across the parallel combination. So this voltage divided by 10 ohm will give you I1. This voltage divided by 10 plus J 3.14, that will give you I2. Voltage divided by 10 minus J 3.18, that will give you I3. So equivalent impedance can be found out using the equation. Say like in DC circuits, 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3, etc. Like that same equation can be used here. So 1 divided by Z equivalent is equal to 1 by 10 plus 1 divided by 10 plus J 3.14 plus 1 divided by 10 minus J 3.18. So 1 by Z equivalent is equal to 1 by Z1 plus 1 by Z2 plus 1 by Z3. So this can be solved as 1 by Z equivalent 1 by 10, 1 by 10 plus J 3, 4, 1 plus 1 divided by 10 minus J 3.183. So these denominator quantities convert to polar form, divide and add, you will get 0.2818 angle 0.06. Angle can be neglected. So Z equivalent is 0.2818 angle 0. No, 1 by Z equivalent. So Z equivalent is equal to 1 divided by 0.2818. That is 3.548 angle 0. So Z equivalent can be found out by this method, and voltage can be obtained by, so total current we know that is 10 angle 0. 10 angle 0 into Z equivalent will give you the voltage. So 10 angle 0 into Z equivalent is 3.548. So into 10, 35.48 angle 0. 35.468. 35.468. Here it is 35.48. So 35.48 volts. Now I1, the branch currents can be found out by I1 is voltage divided by 10 ohm. I2 is this voltage divided by 10 plus j 3.14, and I3 is voltage divided by 10 minus j 3.18. So the branch currents are, first one I1 is V divided by Z1, that is Z1 is 10 ohm only. 35.4, where it is 468, let's take it as 35.48. 35.48 divided by 10, so 3.547 approximately. Then V by Z2, 35.48 divided by 10.48 angle 17.43, we get 3.38 angle minus 17.43. I3 is V by Z3. P is 35.48 divided by 10.494 angle minus 17.85. That is 3.33 angle 17.7. So these are the branch currents. So what we did, first we found the Z equivalent. Current multiplied by equivalent impedance, that will give you the voltage. Voltage divided by individual impedances, that will give you the branch currents. So the next question is, in the given circuit, if the voltage drop across the 4 ohm resistor is 4 volt, find I and V. I is the total current taken by the circuit. V is the voltage across the entire circuit. So there is a parallel circuit and a series circuit. So here a resistance of 4 ohm and inductive reactance of 3 ohm. The other circuit has got a resistance of 8 ohm and a capacitive reactance of 6 ohm. Say an independent 1 ohm resistor. Now it's given that if the voltage drop across the 4 ohm resistor is 4 volts. So from this information we can find out, let's take this current as I1, this current as I2. So I1 is equal to 4 volt divided by 4 ohm, that is 1 ampere. So it's given that voltage drop across the 4 ohm resistor is 4 volt. From that we can find out the current through that branch, 4 volt divided by 4 ohm. Current through this resistor is 4 volt by 4 ohm. Same is the current through the inductor also. So across this branch, the voltage I am taking it as V1. V1 we can find it out from this information because current through this branch is 1 ampere. Let's take it as the reference. So 1 angle 0. Impedance of this branch is 4 plus J3. So 1 angle 0 into 4 plus J3 will give the voltage across this parallel circuit. That is, it's 4 plus J3, it's 5, it's 5 angle 36.86. 5 angle 36.86. That is V1. So we know V1, so we can find out I2. I2 is V1 divided by 8 minus J6. So I2 is equal to V1 divided by 8 minus J6. V1 is 5 angle 36.86 divided by 8 minus J6 is 10 angle minus 36.86. That is 0.5 angle 73.72 degrees. So we got I1 and I2. We can find out the total current. So I1 is 1 angle 0. I2 is zero point 0.5 angle 73.72 degrees. So total current is I1 plus I2. So I is equal to 1 angle 0 plus zero point 0.5 angle 73.72. So convert this quantity. 1 angle 0 is 1 plus J0 plus zero point 0.5 angle 73.72, convert to rectangular form and add it to total current 1.236 angle 22.83. 1.236 angle 22.83. So that is the total current. Now we found out the total current, we have to find out the total voltage also. For that we have to find out the voltage across the 1 ohm resistor. So voltage across the 1 ohm resistor is current through it into value of resistance. Current through it is same current only, that is I is equal to 1.236 angle 22.83 multiplied by 1 ohm, that is V2. So V2 is same 1.236 angle 22.83 because R is equal to 1. So add V1 and V2, will get to V. So V1 is 5 angle 36.86. V2 is 1.236 angle 22.83. So add it. So convert to rectangular format, add it. So we get 6.21 angle 34.1 degrees. That is the voltage across the entire combination, entire circuit. So what we did, so first we found out the current through branch 1, that is I1, because the clue is given. Voltage across the 4 ohm resistor is 4 volts. So 4 volt by 4 ohm is the current through the circuit. So we took that quantity as reference, 1 angle 0. So voltage across this parallel circuit or between terminals A and B, voltage we are taking it as V1. V1 is equal to I1 into 4 plus J3. Again, from this we can find out I2. I2 is V1 divided by 8 minus J6. Add I1 and I2 will get total current I. Then to find out the total voltage, find out the voltage across the 1 ohm resistor, that is total current into 1 ohm. Same 1.236 angle 22.83. Add V1 and V2 will get the total voltage V. Now next question is a coil of power factor 0.6 in series with a 100 microfarad capacitor is connected to a 50 Hertz AC supply. Magnitude is not given. Voltage across the coil and voltage across the capacitor are the same. Find the resistance and inductance of the coil and total impedance of the circuit. Now it is given that these voltages are equal. VC, I'll mark it as voltage across the capacitor. V coil. V coil is the voltage across the choke coil. Choke coil has got a small resistance and a inductive reactance. It's a coil only. So R is the inherent resistance of the coil, L is the inductance of the coil. So it's given that V coil is equal to VC, voltage across the capacitor is equal to voltage across the coil. Frequency is given 50 Hertz. Now we have to find out resistance and inductance of the circuit. Also, coil of power factor of the coil is given. We take the coil separately, resistance and inductance. I'll take the current as I, voltage is V coil. If I draw the phasor diagram, This is R, this is XL. So I into R, I into XL. This is I and this is V coil. So this angle is phi. So this angle can be found out. Cos inverse 0.6. Cos inverse 0.6 is second 53.13. I think 1 second. 53.13. So phi is equal to 53.13 degree. So tan phi is equal to XL by R. Tan 53.13 is equal to XL divided by R. So XL divided by R is equal to tan 53.13. So cos phi is given, that is 0.6. So cos inverse 0.6 is the perfect triangle of the chalk coil, that is 53.13 degree. So XL, tan phi is XL by R. So XL by R is equal to tan 53.13, that is 1.332. So one relationship you can derive from this: XL is equal to 1.332 into R. This is one relationship. So it's given that power factor is equal to 0.6. So power factor angle is equal to 53.13. So this angle is 53.13 degree. So again, tan phi is equal to XL by R. So tan 53.13 is 1.332. So XL is 1.332 R. Also, now capacitor value is given, that is 100 microfarad. You can find out capacitive reactance, that is 1 by 2 pi Fc or 1 by omega C. You will get it as 31.84 ohm. So capacitive reactance is 31.84 ohm. So from the given data, that is voltage across the coil is voltage across the capacitor. And it's a series circuit. The same current is passing through the chalk coil as well as the capacitor. So I into impedance of the coil is equal to I into capacitive reactance. I into what is the voltage across the coil, chalk coil, that is I into impedance of the coil. What is the voltage across the capacitor? I into capacitive reactance. So impedance of the coil is same as capacitive reactance. So capacitive reactance we have found out, that is 31.84 ohm. So impedance of the coil is equal to 31.84 ohm. But impedance of the coil is also is equal to R square plus square root of R square plus XL square. So from this you can find the relation Z square is equal to R square plus XL square. That is 31.84. This is not 3, sorry. Z is equal to 31.84. So 31.84 square is equal to R square plus XL square. And here we got another relation, XL is equal to 1.332 R. So 31.84 square is equal to R square plus 1.332 square into R square. So solve this equation, we can find out the value of R. So that is 31.84 square is equal to R square plus 1.332 or the whole square. Solving R is equal to 19.1. And XL we can find out Z square minus XL square is Z square minus R square. So XL is 25.47. L is 25.47 divided by 2 pi. A frequency is given 50 Hertz. So XL divided by 2 pi f will give you the value of inductance, that is 81.1 millihenry. And total impedance of the circuit also we have to find out. So total impedance of the circuit in that is 19.1 plus J 31.84 minus, so R 19.1 plus, that is the resistance, then inductive reactance and capacitive reactance. Inductive reactance 31.84, capacitive reactance, sorry, inductive reactance is 25.47 minus J, capacitive reactance is 31.84. R plus JXL minus JXC. So higher value minus, so magnitude of impedance is equal to square root of 19.1 square plus 25.47 minus 31.84 square, or 31.84 square, 31.84 minus 25.47 square. Like that also you can take. So Z is equal to 20.13 ohm. Total impedance. Magnitude of the total impedance is 20.13 ohm. So what we did here, so the given clue was voltage across the coil is voltage across the capacitor. Capacitor value is given, so we can find out the capacitive reactance. Then once capacitive reactance should be equal to the impedance of the coil, because these two voltages are the same. So capacitive reaction should be equal to impedance of the coil. Impedance of the coil is square root of R square plus XL square. So R square plus XL square is equal to 31.84 square. Then power factor of the coil is given. From that we can derive this relation. 1. XL is equal to 1.332 or then we can solve the problem. Next is two impedances Z1 and Z2 are connected in parallel and the combination is connected to an AC supply. If the current through Z2 is 10 ampere, find the total current. Draw the phasor diagram. Now current through Z2 is given, that is 10 ampere. So 10 ampere into Z2 will give you the total voltage across the combination. Voltage divided by Z1 will give you I1. So I1 plus 10 ampere, that is the total current. So B is equal to 10 angle 0 into 6 minus J8. Then I1 is equal to, we have to multiply this, that is, write it as 60 minus J80. So I1 is 60 minus J80 divided by 3 plus J4. I is equal to I1 plus I2. I is equal to 10 angle 0 plus this is 10 angle 0 is I2. I2 plus I1. I1 we have to solve this. So voltage across the parallel combination 10 angle 0 into 6 minus j8 100 angle minus 53.13, that is the voltage. 100 angle minus 53.13 degrees. Then I1 is equal to this voltage divided by 3 plus j4. 100 angle 53.13 divided by 5 angle 100 angle minus 53.13 divided by 5 angle 53.13, you'll get it as 20 angle minus 106.26. Then total current is, this is I2 plus I1, 19.69 angle minus 77 degrees. So the quantities we have to draw the phasor diagram. That is, I2 is the reference. I2, that is 10 angle 0. Then voltage is 100 angle is equal to 100. This is 53.13. Then I1 is 20 angle minus 106. I1 is, this is 20 ampere. This total angle is 106 degrees. 106.26 degrees. So total current is minus 77. No, 19.69 angle minus 77. So draw the, complete the parallelogram, draw the diagonal. This is the total current I. This angle is 77 degrees. Once more I'll draw it. I2 we are taking it as the reference. This is I2. Then V is lagging the reference by an angle of 53.13. I1 will come in this quadrant, that is 20 angle minus 106 degrees. This is 106.26. Resultant current is, draw the parallelogram and complete the diagonal. This angle is 77 degrees. That is the phasor diagram. Now, in the figure given, the ammeter reads 10 ampere, find the voltmeter reading. Now we can find out the, so let this current be I1, let this current be I2. So voltmeter reading can be found out by multiplying magnitude of I2 with 6. I2 into 6 will give the voltmeter reading. So I2 is equal to 10 angle 0 into 4 minus J3 divided by sum of the impedances, that is 10 plus J5. So this is 4 minus J3. This is 6 plus J8. So total is 6 plus 4, 10. 8 minus 3, 5. So I2 is 4.472 angle minus 63.42 degrees. So magnitude of the current is 4.472. So voltmeter reading is equal to 4.472 into 6. That is 26.83 volts. So total current is given. So to find out the voltmeter reading, we have to find the current through the lower branch, that is I2. I2 into 6, magnitude of I2 into 6 will be the voltmeter reading. So we found out I2 into 6. That is the voltage across 6 ohm resistor, 26.83 volt. That is the voltmeter reading. So that's all for today's session. Thank you for watching this session. If you like the video, please share it among your friends, and also press the bell icon for further notifications. Thank you.